Okay, let's talk about quality of service common misconceptions. We're going to talk about 10 misconceptions. In this case, we're going to go for number one. Quality of service features are implemented the same in both multi-layer switches and in routers. That will be wrong. In reality, the implementation of quality of service has been historically different. For instance, routers usually offer MQC. With MQC, you can configure your quality of service with class maps, policy maps, and then attach these policy maps in the input or output direction in your interfaces. With switches, historically, this has not been the case. You will need to use this set of commands in all switches, this set of commands in more recent switches, and they will always offer an incomplete version of MQC. However, with more recent switches, for instance, the Catalyst 9000, they include a really complete version of MQC that resembles pretty much what we have in routers. The gap has been reduced. However, difference still exists. For instance, in routers, you cannot use this command to trust devices. You cannot use table maps, and so on. So be aware that difference exists. Misconception number two. I have a rate limit in one of my network devices. It is not quality of service, it's just a rate limit. That will be wrong. If you are using rate limit, then you're using policing. Policing is one component of quality of service. Therefore, you are actually doing quality of service. Misconception number three. You only have to classify your traffic once. That will be wrong. Classification happens almost everywhere or everywhere in a well-deployed end-to-end quality of service network. So you have to do classification here, classification here, classification here in the input and output direction, not only once. Classification only happens at input as misconception number four. That will be wrong. Classification happens everywhere at input, at output, at every single device. So for instance, for traffic that goes in this way, you have to classify here at input, classify here at output, classify here at input, classify here and output, classify here and input, classify here at output. And for traffic that goes the opposite way, you will have to do the same but in the opposite direction. So notice that this involves a lot of work. That is why some Cisco tools such as Auto QoS exist to save you a lot of time when doing this configuration. Notice that in this scenario where we only have 3 devices, we are going to do 12 classification actions in total. Misconception number 5. I read somewhere that classifications only happens at the trust boundary. That is wrong. We just said that classification happens everywhere in your network. The thing here is that remember that when you have a trust boundary, you really want to mark your traffic there. You really want to identify your different type of traffic flows that you're receiving at that point in the network, because you don't really trust the markings that this traffic is arriving with. You want to mark your traffic there, and in order to mark your traffic there, you have to classify it there with a really high sense of attention to detail. So your classification at this point will have to be created the most carefully and complex. For instance, you could use mbar combined with a set of complex access control lists for your classification at that point in your network. That doesn't mean that you are not going to do classification in other parts of your network. As we saw previously, classification happens almost everywhere. However, the classification that you're going to do at your trust boundary will be the most complex classification that you are going to perform in your quality of service deployment. Misconception number 6, classification exists only to mark traffic. That will be wrong. Classification exists as a quality of service feature for several purposes, not only for marking. For instance, classification can be used to place different type of traffic into different queues. So you can have one queue that will be the priority queue, another queue that will be given a bandwidth guarantee, and so on. So classification in this case is helping me place different types of traffic into different queues, not only to mark traffic. Misconception number 7. Marking only happens once in your network, usually at the trust boundary. We already said that we can have a trust boundary in your network. That is the place where traffic arrives into your network and you are not willing to trust whatever markings this traffic is arriving with. And you need to mark traffic at that point. And you will usually do that. You will mark traffic according to your rules. That doesn't mean that this is the only point in your network where traffic gets marked. For instance, you could configure policing at some other point in your network for traffic that exceeds your policing. You can configure that traffic in order to be remarked rather than being dropped. So this traffic is being marked again, not only at the trust boundary, but on another place in your network where you have policing. Or for instance, if you're connecting your network to a different quality of service domain where other people is configuring quality of service, mutation can happen. So not only at the trust boundary the traffic is marked, that is the point. Misconception number 8. Classifying and marking come always together. They are inseparable features. That is a common misconception. That will be wrong. That is a common misconception that people have when they are starting to learn quality of service. You can do classification without marking for many purposes. For instance, you can use classification to place different types of traffic into different queues, and you can do marking without classification. For instance, the very early Cisco switches will only let you do marking with policing. Actually, the first way that existed to mark traffic was policing. So you can have these two features working separately. They usually work together when you are going to do marking at the trust boundary. At that point in your network, you're going to do classification and marking, and they go together in that point in the network. That doesn't mean that they are always going to work together. Misconception number 9. The bandwidth command guarantees bandwidth just as with the policing command. That is a common misconception that will be wrong, because the bandwidth command guarantees that certain type of traffic will have a minimum available bandwidth. This certain type of traffic will be able to use more if more bandwidth is available. However, with policing, you are going to guarantee that certain type of traffic will use only a maximum amount of bandwidth. Even if more bandwidth is available, this certain type of traffic will not use any more bandwidth. I know there are some details about policing, such as the peak rate, excess bursts, and so on, but we are not going to talk about that. So let's say that we have this available bandwidth here, and then at some point in time, your interface no longer has available bandwidth because congestion happens. So if you use the bandwidth command for certain class map, the traffic that belongs to that class map will be able to freely use wherever bandwidth is available in your interface. But once congestion happens, then that traffic will only use the guaranteed traffic that the bandwidth command previously set up. Compare that with the policing command. With the policing command, certain type of traffic will never go beyond a certain rate. Even if bandwidth is available on the interface, the point of the policing is that this traffic always has to abide by a certain rate, no matter if the interface is congested or not. That is the difference between the bandwidth command and the policing command. Misconception number 10, end-to-end quality of service is not really required. That will be wrong. In order to have a successful successful quality of service deployment, you have to configure quality of service end-to-end. In all your routers, in all your switches, if you're going to go through a one provider, you have to provide this carrier with your quality of service settings that he has to abide by. At all your microwave hubs, at all your PON hubs, at all your wireless devices, you need to configure quality of service at every single point. Otherwise, you cannot guarantee good experiences with voice over IP calls or video conferences and so on. That's it.